Hi, everyone. We still have 10 minutes before the session starts. So please feel free to ask questions. Yes, there are no questions right now. Let's do a quick recap of what we have discussed up to now. So we finished the previous session with hands-on 21. The hands-on 21 was where we escalated our privileges from domain admin to enterprise admin by abusing the set history with the help of Kirby TGT hash. So this hands-on reinforced what we discussed as in the very first session as almost the very first thing. That is, in Active Directory, forest is considered to be a security boundary. And this hands-on actually cleared that. I mean, it was pretty clear after doing this hands-on that that's true. So for example, this is what a typical multi-domain environment or a multi-domain corporate environment will look like. There would be, let's say, a root. Let's call this what, acme.corp. And there would be US, let's say, .acme.corp. And there could be in US, let's say, SFO San Jose LV or something. Let's say SFO.us.acme.com. There may be other locations as well. There could be, let's say, another one. A lot of organizations keep the US as a separate entity, and then there is a North America entity as well. And whatever. I mean, let's say there is EU and EMEA and so on. Now, what the hands-on 21 reinforced was, let's say, in EU, you have, let's say, DE, or you have BE, and so on. Let's say the most of the engineering, that is the tech of acme.corp, is focused in SFO. And there would be a difference in security posture of this domain and, let's say, this domain. Right? Now, having a single forest for all the domains, that is, having a single forest environment, means that, let's say, if this is compromised, we can go all the way up to, let's say, the forest root. And once you are on the forest root, once the forest root is compromised, all the domains are assumed to be compromised. And this is working as intended. There is absolutely no way that you can, let's say, isolate domains within a forest. This means everything is compromised. That is what we practiced and understood using the hands-on during the hands-on 21. A lot of times, organizations would like to believe that, okay, if my DE domain was compromised, I'll rotate the Kirby TGT hash or the secrets here, here, and here. Now, please absolutely do not think that. Why? Let's say you change the Kirby TGT hash here. Meanwhile, the attacker would have the trust key here, the trust key here, Kirby TGT here, and all the domains. If you rotate all the curve TGTs, the attacker may have the trust keys as well. If you rotate all the curve TGTs and all the trust keys, meanwhile you are rotating them, the attacker will use any one of them, any one of the existing ones, to get a copy of the new one. That is said easier than done, but even if a single domain admin, what does this mean? Even if a single domain admin in the entire domain is an entire forest is compromised, the only way to get the absolute trust back in your environment is to rebuild the entire forest. And that's no mean task. I mean, no, that's like rebuilding the entire organization. But unfortunately, that is the way. And sprinkle into this, magic, sprinkle into this something like, let's say, we have for TechCop, trust with an Azure AD Forest as well. Sorry, an Azure AD tenant as well. Now your blast radius does not stop here, right? The damages do not stop here. This also means that now your AAD tenant or tenants are also at risk. And this actually increases the risk multifold. Because it is, although Microsoft recommends to have a single tenant, if you're using hybrid identity and if you have, let's say, a single forest, Microsoft recommends to have a single tenant. But let's say if you have multiple tenants that are related or not related, if you have multiple tenants, then those are at the risk of compromise as well. So this signifies the importance of domain admin account. Treat it as absolutely top tier account. All right. If you are using a hybrid identity, then think of a DA also as a GA, a global admin, the God mode in Azure. So think of it that as well. Do not think that, okay, if I have domain, if your domain admin is compromised, do not think that it will not impact your tenants, your Azure tenants as well. That is also at risk of compromise. It's almost for sure that it will be compromised. Why? I mean, we have not covered all of it, but how is hybrid identity achieved? There is an Azure AD Connect server that allows the hybrid identity, the one in our lab, USAD Connect. Now, using PHS, PTA, or Federation, if you're using any of these methods, if you have domain admin privileges, we saw it for PHS, that holds true both for PTA and Federation as well. You can actually compromise entirely, absolutely, the cloud environment as well. All right. So just wanted to highlight the importance of this, or the importance of DS actually. The question is, when I add myself to another group, for example, using a service abuse, and we have to log off and log on again in order to obtain a new access token for our session with the new rights assigned. How does this apply for a non-interactive logon session? We often do not have interactive RDP session. Is it simply not required to renew for the changes to take effect for that matter? And group, that is usually, that can be achieved by spawning a new process as well, right? Or by purging all the tickets, but not as, I mean, not, no guarantee that it would work. I mean, in case of RDP, if you log on and log off and log on, then you absolutely have a new access token, and therefore, let's say, new group memberships. All you need to do is to refresh your access token, so you can even purge all your current tickets, start a new process, and I believe you would still you would now have new group memberships reflected in your access token. All right. Okay, now we can start the session. So this explains the importance of domain admins and how. I mean, a lot of times I've seen organizations running services using a domain admin account. So think about stuff like this before you go ahead and, I mean, if you see something, say something. If you see that your organization has a vendor that insists using domain admin privileges, or you have services that run with domain admin privileges, try to contain that. Otherwise, this is a very real risk. A lot of organizations do get compromised because of this. Excessive domain admins, that's one of the biggest problems that enterprises face. Now we have multiple ways using which we could get enterprise admin privileges in the TechCorp.local for us. That is, we now have multiple methods to escalate to enterprise admin in TechCorp.local. Now we have 5 or 6 other forests in our target environment. We are thinking of the TechCorp organization as a true multi-forest organization that utilizes forest security boundary to segregate at least some of their infrastructure. Let's see how we can move across forest. One is Kerberoasting. Please keep in mind that it is absolutely possible to execute the Kerberoasting attack across forest trusts. If there is a bidirectional or unidirectional trust, that is, if you have access in a trusting forest, you can absolutely enumerate service accounts there, request TGS for them, and save them to disk and brute force them offline. Right? How can you enumerate service accounts across forest trusts using Power View or AD module? You can do that. We are simply doing this. The command that we used earlier, we simply list all the trusts. For each of the trusts, we list all the users whose service principal name is not set to true, and we are querying each server that is returned from left side of the pipe here. So let's say if this returns 5 trust objects, then we check for a service account in all those trusting forests. Once we have found one out, the rest of the process is exactly the same. We request a TGS, brute force it offline, or if you want, I mean, we can use Rubius, or if you want, we can use PowerShell as well for that, just like the normal Kerberoasting. And that's it. I mean, I just wanted to point out that it is possible. Unfortunately, I've not seen many penetration testers or red teamers trying this across a forest trust. It is absolutely possible. Just keep this in mind that if you're using this in case of PowerShell, not only would you need FQD and fully qualified domain name of the target object, you also need to specify where does it reside. No such requirement for Rubius that handles it by itself. Here you need to specify that. Right. This brings us to hands-on 22. Find a service account in the EU.local forest and Kerberoast its password. Do that. So let's first enumerate service accounts in EU.local. We will start an InvisiShell session here. Import the AD module. Now, using the command that we had in the slides, list all the intra-forest trusts, that is forest or external trusts for each one of them. List all the users that are service accounts that do not have their service principal name set to null. So in EU.local, we found out that there is Kirby TGT and another account called storage SVC that has service principal name set. For storage SVC, the service principal name is MS-SQL SVC on EU file. So let me remove the previous text file, the file that contained the hashes. So let's using Rubius. Let's request the TGS. Please remember always not to run Rubius from an individual shell session. It would not work. So we request hashes for storage SVC from u.local, and we want to save it to this file. This is returned to the file. Now using, let's check if we have the ticket. Now using John the Ripper in the lab, or Hashcat in an, if you feel like Hashcat, you can use that one as well, although that's not present on the student VM. We brute force the hashes offline. And because it was already present in this dictionary, as you could see, we can actually brute force that. Please note that the password was so easily guessable because this is a lab environment, right? Yeah, I mean, you can think of that, but please always keep this in mind. Users are not the best ones when it comes to, I mean, humans are not the best species when it comes to choosing passwords. All right, if you are testing a target environment that has, let's say, 10K users, at least a handful of them would be using, let's say, because this is April at 2022 as the password. And the probability of that increases if the target organization has, let's say, a 30 days password reset policy. That is, if their users need to change their passwords every month, then the probability of their users choosing passwords like that also increase. All right. Nonetheless, we got the password, and that is, I mean, this was a pretty simple one, right? That is what we were asked to do. All right. There is a question. I think I heard you often say that UAC is going away and does not really matter. Don't recall saying that. Okay. However, I feel there are still challenges at times to bypass it, especially when fraud helper, etc., can be detected. What is your opinion on that matter? Does it still bother you at all? UAC is a pain. I mean, I never said that. I don't recall saying that it is going away. UAC is absolutely always going to be a pain. All right. Yes, just like AMSI, there are so many bypasses of UAC, but anything that forces an attacker to execute an additional step to avoid or bypass that helps in generating detection. Right? Let's say if you have, even if we talk about MZ, let's say an attacker uses an MZ bypass that is detected because it was an obfuscated script or the bypass itself was no signature. You have an IOC right there. Same goes for UAC. As you mentioned, I'm root. Let's say fraud helper is detected. And you have an IOC right there. Right? So UAC, of course, it bothers absolutely all the attackers, and that is why there is always ongoing research on finding new methods of UAC bypass. Especially when you talk about at least the initial access. At that time, both local privilege escalation and UAC are a pain. All right, you would rarely find a user opens up your attachment. Let's say you sent an Excel attachment to a user. Rarely would you find a user who would open that from a high integrity process. So even if you get a call back from an admin user, it would be from a medium integrity process. To be able to escalate to a high integrity process, that is when you need UAC bypasses. So yes, it is absolutely a pain. It's a PETA, and it is not going anywhere. UAC is something that has helped Microsoft thwart a lot of attacks, so it is not going anywhere. So what we did here back on our hands-on 22, what we did here was by abusing or by executing Kerberos across forest, we got sort of a foothold in the EU.local forest. Now let's see if we can execute constraint delegation with protocol transition across forest. Please note that the constraint delegation does not work across forest trusts. However, once we have a beachhead or a foothold, then we can use it. So for example, we have a foothold now in EU.local. Now we can see if there is any constraint delegation on EU.local that can be abused. Now, once we can, of course, enumerate that using the same or similar commands, we just need to run it against EU.local. If I run a AD module command that enumerates a constraint delegation in EU.local, we get to see that it is storage SVC, the account that we have just now compromised, that has MSDS allowed to delegate to, that is, it can access some of the services on EUDC. Time and NM agent. These two services are the ones that storage SVC. So how do you read it now? Because we now understand constraint delegation. We read it this way. This means that storage SVC can access time and NM agent on EUDC as any user, including the domain admin of EU.local. What we also discussed, if you recall, was thanks to how services work in, or SPNs work in Active Directory, we can not only the time and NM agent service on EUDC as any user, we could also access any other service that uses the same service account. For example, once again, services like LDAP, HTTP, host, RPCSS, all of them can be used or abused here. So once we know that, we can simply go ahead, request an alternate ticket using Rubius. Once we have the ticket, for example, if we are requesting it for the LDAP service, then we can go ahead and run the DC sync attack. All right, so both of these hands-on 22 and 23 are pretty similar to what we have done earlier. However, the point here is, the point of both of these hands-on is, if you are targeting a true multi-forest environment where there are resources that are accessible across forest trust, you will always find issues like this. Look for them, and then you will be able to abuse them. So our hands-on 23 tells us to enumerate users in the EU.local domain for whom constraint delegation is enabled. We found out that it is for storage SVC. Abuse the delegation to execute DC sync attack against EU.local. Let's do that. So we'll first compute the NTLM hash of storage SVC using Rubius. So using the hash module of Rubius, we specified the password of storage SVC, and we wanted, the hash module will compute the hash for you. So that is the RC4, that's the AES key, whatever you want to use here. So if I use this RC4 here, let me copy that. So what are we doing here? Using Rubius and its S4U module. Because storage SVC has constraint delegation enabled for NM agent and time on EUDC, we want to request a TGS for the administrator of EU.local, but for the service LDAP. Have we got the ticket? Yes, we have. Now, what does this mean? What can we do? We can run DC sync attack, for example. So if I use sharp cards here, we want to run DC sync for EU administrator in EU.local available on this domain controller. See that? Similarly, of course, we can, in place of administrator, we can do it for the copy digit user as well, so that we can create golden tickets for EU.local. Right? There was a question, any reason why LDAP was used in this example, and it was already answered, because that allows us to run a DC sync attack. So now we first executed Kerberos to get a foothold on EU file. Then we abused constraint delegation to compromise EUDC as well. So that would complete the compromise of actually of EU.local. If we take a step back and talk about unconstrained delegation again, recall that the printer bug and its abuse work the forest. That is, you can request a TGT for the forest root domain controller account as well. However, it also works across a two-way forest trust, but TGT delegation must be enabled in that case. So if your current forest, the forest that you have compromised, has a two-way forest trust and has TGT delegation enabled for another forest, and you can use printer bug to compromise the trusting forest as well, the other forest as well. However, please note that TGT delegation is disabled by default and it must be explicitly enabled across a trust. Right? In our lab, TGT delegation is set from US vendor.local to techcorp.local, but it is not set for the other direction. That is, TGT delegation is not set from TechCorp to US vendor, but set from US vendor to TechCorp. Once you have that, you can simply, I'll come back to this slide in a moment, but once you have that, you can simply run the exact commands that we have used earlier. All right, in our lab, US web has unconstrained delegation enabled. You run Rubius in monitor mode there and try to force an authentication from US vendor DC, the other forest in this case, try to trigger an authentication from there to get the TGT of US vendor DC, that is the other DC here, right? Now, a question here is, how would you enumerate if TGT delegation is enabled across a forest trust? Now, unfortunately, I am unaware of any such command that can do this from your attacking forest. I mean, the AD module command, this one, if you run this, so if I run this, let me show you that actually. There seems to be a bug in the AD module. If I run this here, you would see that TGT delegation is shown to be false. However, if I run this on US vendor DC, the same command would show that TGT delegation is set to true. Let me actually show you that. So I just need to log on to the DC. Just give me a second. I want to log into US vendor DC. Looking up the password for the DC. Hey. So here on US vendor DC, that is our target DC. Now there, if I run this command, you would see that TGT delegation is listed as true. And please note that even in this case, even when we ran from our student VM, we were actually running this on US vendor.local. So that seems to be a bug with the AD module, which we can actually ignore. I mean, what is the actual way of enumerating it now? This command. We need to run this on the DC of the target forest. I mean, that shows you that delegation is enabled or not. However, that doesn't make sense. Why? Because we have to run that on the DC. So how would you enumerate that then? And what is the point? Exactly, there is no point. I mean, just give it a shot. There is, I mean, enumeration is something that you should always try and execute. But in this case, if you cannot enumerate, just give it a shot and see if you can actually force the DC of the other forest to authenticate to a machine that has unconstrained delegation in it. Right? And that is actually our hands-on 24, and that's pretty straightforward, to be honest. All we need to do is, I mean, the exact same thing. We will first access this web. So let's start our process as webmaster, the user that has administrative access to US web. Copy Rubius on the US web machine. Access the machine. And start Rubius in monitor mode. However, this time we are targeting US vendor DC dollar. Now on the VM, on the student VM, that is our attacking machine, assuming that we can reach over the network to US vendor DC, let's force authentication. We got an access denied there. But if we see here, you would still see a TGT for US vendor DC dollar. Let's copy that. And here we would simply run our Rubius PTT to pass this ticket. And then let's say using shortcuts, we can run DC sync and get the Kirby TGT hash for US vendor.local. Right? So, oops, this actually completes compromise of US vendor.local as well. Now, let's continue our discussion on cross-forest attacks. Now, we saw earlier the question is, if TGT delegation is not enabled by default, how to activate it on the target DC? No need to activate it on the target DC. If TGT delegation is used, as I said, we are assuming the TACOP organization is using a functional multi-forest environment. So if TGT delegation is enabled for business purpose, that is, it is actually used, only then you would be able to use it. I mean, if you already have access to the target DC to enable delegation, you would not, I mean, if you already have access, why would you require this? This command does not enable it. This command simply tests for it. When we say enable TGT delegation, it simply checks for it. It does not enable it. All right. Now, here is a question for you all. We call our escalation from domain admin to enterprise admin by abusing the trust key. All right, recall that our own DC provided us an inter-realm TGT that was encrypted using the trust key. When we presented that inter-realm TGT to the parent root DC, the only validation that was done was if the parent root or if the forest root can decrypt the TGT. So it turned out that if we have the trust key with us, we could forge our own inter-realm TGT and escalate to enterprise admins. That was the case within forest. Now across forest, do you think that we would be able to escalate to enterprise admins across forest by abusing the trust key? If yes, why? If no, why? Once again, can you escalate to enterprise admins across forest trust by abusing the trust key? There are a couple of answers that you would need SID history. I'll come to that. There are a couple of correct answers already there. Anyone else? Would anyone like to say yes? Right, so all of you know that. There is, whenever we talk about the forest boundary, there is something called SID filtering. That strips off all the machine generated, all the important SIDs, that is everything between 500 and 1000 would be removed. So if you have a SID history of enterprise admins or enterprise domain controllers or domain admins or whatsoever, that would be filtered out at the forest boundary. So what would be the use case here or the abuse case here? you would still be able to access explicitly shared resources. So what you would have is, let's say you have domain admins privileges here. Then this would still allow you, though, let's say there is a resource here, let's say this application server. And on this application server, only the DAs of, let's say in our case, this is going to be eu.local, of eu.local can access. So what does this mean? This means that although you would not be able to escalate privileges in the other forest, what you would still be able to do is to access the resources that are accessible to high privilege users of your forest, but the resources are in another forest. So if this application server is accessible only to domain admins of your current forest, that is something that you would still be able to do. Right? Now, a question or comment I get when I explain this is, I mean, so what? We already have domain admin privileges in our current forest. Yes, you do. But this is one more way. This is not an implicit trust key. This is an explicitly established trust. So this trust key would have a lot longer life than your implicit trust key. Right? So you can use this as a sort of a method to maintain your high privileges from this forest on another one. And who knows, I mean, there is no built-in way or working as intended way, but who knows if there is a way to escalate your way back here by, let's say, if you can access this application server, what if there is a way to go back to escalate to the DC in the other forest that would be working as intended? Right? But coming back to what we have at hand right now, we can access only explicitly shared resources. For example, let's say there is a file share called eu-share on eu-vendor DC. What is eu-vendor DC? Eu-vendor.local, that's the forest that has a trust relationship with eu.local here. So if there is a file share or any other resource that is explicitly shared, then we can access it. Note that now we are hopping trusts. This was our first sort of hop, not first hop, this is where we start from. We go to this trust, and from there we go to the second one. Can we enumerate these shares? Yes, using NetView you can. I mean, the idea is, if you have compromised eu.local that has access to some of the resources in EU vendor, it is assumed that you would go through, let's say, the documentations, files on user machines, access history, etc., to check what can you access. However, you can also enumerate that. So once you have injected, let's say, the CIFS ticket for eu-vendor-DC, then you can use NetView to actually enumerate that as well. And not only shares, you can actually inject TGS for a specific resource. Please note that TGS are bound to service principal names. So if you create a service ticket, if you forge a service ticket for CIFS on eu-vendor DC, you would be able to enumerate shares only on that. If there are other computers in the target forest, then you have to create a SPN or a ticket for each one of them. So you request a CIFS on eu-vendor DC, CIFS on any other server, and then you can run NetView. All right. So the step is the same. We extract the trust key and forge a ticket. Is it clear, a while loop, about how can we enumerate that? If not, then ask me while I'm demonstrating that, and I'll show you. So using Mimicards or any of its variants or whatever the tool that you like, we can extract the trust key for the trust between eu.local and eu-vendor.local. Once we have the trust key, we forge an interforest TGT and then use it either with Kikyo, or Rubius to request or get a TGS. All right, so let me show you it up to here. We'll come back to this discussion on SID filtering in a moment. So hands-on 25 has two tasks. First, we are going to complete the first one, access EU share on EU vendor-DC. So first, we need to access EUDC. Why? Because we cannot access EU vendor DC directly. The other forest, we cannot access it directly. Right? There is no network connectivity with EU vendor.local. So we have to access it from EUDC. We already have the Kirby TGT hash for it. So let's create a golden ticket for EU.local using better safety cards. Oops, no need to run KList right now. Let's extract the trust key by using DC sync. What are we DC syncing for? The NetBIOS name of the trust. Or we could use anything else as well. I mean, it depends on what you like to use. We could use any of these commands. I just chose the second one because we have not used that up to now for extracting the trust key. All right. Let's run this. And we get the trust key here. We copy that. Now we have the golden ticket for UDC here in this process. So let's use that to copy some tools over to EUDC. We'll copy better safety cards and Rubius right now. Access EUDC. And now we will use better safety cards that we have copied here to forge an interleaved TGT using the trust key that we extracted. So using vector safety cards, we are forging a interleaved TGT for the trust between EU.local and EU vendor.local. This is the trust key that we extracted by running DC sync. Note that we are still injecting a SID history of enterprise admins just in case it was enabled. I mean, actually to see how SID filtering works. So let's run this. And you would see that the file, the TGT is generated and saved to this file. But we have not presented that yet to EU vendor DC. Let me show you how SID filtering looks like. You have to log on to EU vendor DC for that. Just give me a moment. Here on EU vendor DC. Take a look at the security logs on the DC. Now, there would be no log right now because we have not presented the TGT yet to EU vendor. Let's do that. Excuse me. Using Rubius and its Ask TGS module. We use the interim TGT that we created above. Sorry. To request a TGS or a service ticket for CIFS on EU vendor DC. Now, if you look at the logs here, you see that 4675, couple of 4675 audit failure that are generated here. This is your SID filtering in action. This shows you that, okay, EU administrator. So 4675 is SIDs were filtered. EU administrator tried, or there was a ticket from EU administrator that had a SID of EU vendor enterprise admins that was filtered. That's what this means. Can't be clearer than this. That is your SID filtering in action. However, SIDs are just stripped off from the TGT or from the request. That does not mean that you were not a TGS. All right, there is a 4769 right there, just above it. All right. So we still got the TGS. Now, if I run that view, let's say on EU, let me copy that. Hope I'm using the correct splash here. So you could see that these are the shares that are visible. And we can try and access, let's say EU share. We can access it. There is a file called share.txt inside it that you can access. That's the text there. I mean, just a message. All right. A question is, will there be multiple forests in the exam? Yes, there will be. All right. So what we did here was we saw the limitations of trust fee when it comes to cross-forest attack. All right. We saw that SID filtering spoils a lot of fun for us. However, if we go here at and take a look at the SID filtering documentation, there is something interesting that stands out. For the user created identities, all such identities are assigned a SID greater than 1000. So for all those SIDs, those are not filtered at domain and external trust boundaries and can be filtered at member, quarantine, and cross-forest boundaries. What does this mean? This means that if we have an external trust or a forest trust that has SID history enabled, then we can inject a SID history for RID greater than 1000 to access resources that are accessible to that particular identity. Shared a note here. This is noted by Doug Ian here in a very interesting blog post. Right? Now, what does this mean? There are two prerequisites or two settings. In case of a cross-forest trust, we must check if SID history is enabled. Please note that even if SID history is enabled, that would not allow you to inject a SID history for system-related SIDs like enterprise admins, etc. That would still be filtered if SID history is enabled. That is not filtered only in case of PIM trust. But that comes later. So one, we need to check if SID history is enabled between EU and EU vendor. Second, we need to find out any identity with SID greater than 1000 or RID greater than 1000 that we can use. All right. So if we list trusts of EU.local, if we find out that SID filtering forest aware is set to true in the trust attributes, that means SID history is enabled. And if we enumerate identities that has RID greater than 1000, and if there is any such identity, we would possibly be able to abuse it. So let's enumerate both of these things. First, let's check if SID history is enabled. But before we do that, we need to run both of these commands on UDC. Both of them are partial commands. So let's copy over InvisiShell to UDC. Right? Run InvisiShell so that we do not leave partial related logs on UDC. First, let's list the trusts. So there is a trust relationship with our current domain. That is something that we are not interested in right now. And then there is a trust relationship with EU vendor that has SID filtering forest aware set to true. That means SID history is actually enabled between EU.local and EU vendor.local. Next is, let's check if there are any groups or users or object that has SID history. So no, sorry, not SID history, SID greater than 1000. So for example, if you look for group, what are we filtering all the groups for? Any such group whose SID is greater than this. What's that? That is the SID of EU vendor.local. And that's of course 1000. And we are querying that to check if there is any such group. So there are three such groups: DNS admin, DNS update proxy, and a group called EU-admins. So let's try some things with EU-admins. Now, what is this some things? What can you do in a real assessment if you find something like this? What are your options? Enumeration. The more the enumeration, more the time you spend on enumerating EU vendor.local now, more are your chances of success. For example, you can try and see what are the how many computer objects are there in the top. I mean, all the enumeration that we did in session 1, that is everything you may like now to do against EU vendor as well. Now, how do you enumerate that what machines or services does the EU admins group has access to? If you are lucky, you can simply get that by, let's say, enumerating the restricted groups. If, let's say, the group is added to a local admins group, using restricted groups, you can enumerate it right from here. Other than that, tools like Bloodhound may help. Or you can keep running individual enumeration commands here. So the idea is to simply go and check if this group has access anywhere. And that would take a lot of time. Be patient. All right, a real assessment is not a lab environment where we know that what is the command that we would like to run. There we need to discover stuff on our own. So after a lot of trial and error, this is something that would work for us. Note that we are injecting a SID history of the EU admins group now, 1103. Right? That is what we are injecting right now. So what are we doing here? Using the trust key between EU.local and EU vendor.local. We are now creating an inter-reel TGT with SID history of this EU admins group. Let's do that. And now using that particular interviewing TGT, we are going to request a TGS. TGS for, let's say, HTTP on EU vendor-net. What is the EU vendor-net? The other machine. The other machine in EU vendor. Why are we choosing that machine? I mean, it's random. We are trying stuff on almost all the machines there now. All right, so let's request a TGS. I need to exit from NVC shell here. Forgot that. Rubius would not work from, this is an NVC shell session. So let's exit from there. And now if I run this, we have that now. We have the ticket. Right? And now, because we have injected a ticket for HTTP, that means WinRM. If now we want to go ahead, we can try if we have access to EU vendor-net. Okay, this was supposed to actually run. Yeah, worked. Right, and here you would see on EU vendor DC that there was a successful 4769. That is a Kerberos service ticket granted. A log that was what that is what 4769 is. Now here we have access as administrator. We still, our SID is for the EU administrator user because that is the user that we impersonated when we created the TGT. We impersonated the administrator of EU.local. All right, so our SID is for the administrator of EU.local. We are member of domain admins of EU and all there. We have that's what our current access token contains. We have membership of EU vendor, EU admins, and built-in administrators on EU vendor-net. That is why we are able to access it using WinRM. All right. Now that is how we can move across forest trusts. Please absolutely always note that in an actual functional multi-forest environment, you would always find out services and resources that are accessible across forest trust. Otherwise, there is no need of having a trust at all. I mean, they could be simply be network segments, absolutely not related to each other at all. Any questions here? Let's talk about another method that helps us in moving across trusts. Is SQL servers. So there are so many SQL servers that you will find in any Active Directory environment. Now, SQL Server integrates really well with the Active Directory trust. One of the biggest reasons for that is you can actually map Windows users, that is domain users, to database roles in a SQL server. So for example, let's say you compromise a user called, let's say, MGMT admin, for example. Now, it is possible that that user has SA, sysadmin access on a SQL server, or some other access, not necessarily always sysadmin. So it makes sense to always check that if there are SQL servers in the target environment, and if the user that you have compromised, if that has access to any of the SQL servers. Right? We'll take a look at a scenario where we can use SQL Server Trust and database links to move across Forest Trust boundaries. We'll use PowerUp SQL for all of our MS SQL hacker. So first we'll use get SQL instance domain from PowerUp SQL to discover the SQL servers. This uses SPN scanning. That is, it looks for service principal names that begin with MS SQL. That way, even if a SQL server is not connected to a network, not listening on the network, you'd still be able to know that, okay, there is one such SQL server. Then you can, once you discover the domain, you discover a SQL server, you can check its accessibility over the network. And if your current user or the user whose credentials that you specify, if that user has any capability to connect, has the permissions to connect to the target instance, and finally we can gather some information from it. Let's do that. We will import PowerUp SQL here. Run get SQL instance domain. It looks for all those SPNs that begin with MS SQL. There is just one SQL server called US MS SQL that is accessible, that is available in our target domain. Let's see if we can connect to it. I was not expecting this connection failed. So just let me see if I can actually get some info as well. I don't think so I would be able to get anything. Let me log off once. Please note that this requirement to log off and log on whenever we are injecting tickets, that's not because it is in the lab. That is how Windows handle tickets. A question is, are all the authenticated users, do they have public role on SQL Server? No, that's not the default setting. I mean, many organizations keep the setting that way, but that's not a default one. You have to explicitly map the authenticated users group to that particular database role, to the public database role. So now here, if now I try to connect to get MS SQL, you would see that it is accessible for our current user. And if I try to get information from it, we will get some information. So that would mean that we at least have public privileges, public database role on USMS SQL. So the computer name is this, the instance is USMS SQL, domain is US, that is the database or MS SQL service process ID. Service name is MS SQL Server. The service account is a named account US DB service. It supports both Windows and SQL Server authentication. It is a 2017 developer edition, 64-bit. This is our current login, and we do not have sysadmin privileges. Now, for most of the attackers, and unfortunately, mostly for the good attackers, that is red teams and penetration testers, this is where the interest in SQL servers end. The more they see that, okay, they do not have sysadmin privileges on a SQL server, they immediately lose interest. Please always keep this in mind. I mean, please always keep the goal of your assessment in mind. Unless specified otherwise, all security assessments, whatever the name you give to it, you call it a VA or a penetration test or a red team operation or a tiger team operation or purple team or whatsoever, for all the security assessments, there is one common goal, and that is to ensure that critical information is protected. Now, where would you find, what is the place, what is the software, what is the piece of technology that stores information? That's databases, almost always. So please always keep this in mind. Even if you have non-sysadmin access to a database, it always makes sense to check if you can access some information in that database. No, it's fine if you cannot, let's say, enable XPCMD shell and run commands. Even if you cannot do that, always go ahead and check if you can extract some information from it. That absolutely makes sense. All right, do not always run after identities or privileges. Privileges are just means to access information. So if you already have access to a piece of information, then go for it. And that I'm saying from my own experiences. Right? There have been multiple, I mean, I'm lecturing you right now on privileges, but I have been into assessments where we would get access to a database, let's say a SQL server. We would overlook some interesting information. I mean, especially in case of very precisely defined assessments. So for example, in certain red team operations, we would be given a task. So for example, if this year we were doing assessment for a pharmaceutical company. So the goal of the operation was very clear. They wanted us to access the information, any information that is related either to composition of their drugs or anything that is related to, let's say, the complaints or side effects, if you would say. And interestingly, so we started, of course, with the initial access. I mean, we were given both the accesses, a machine on the intranet that is connected to their domain, and some emails. So the idea was to simulate an insider who would allow an external threat actor, or emulate, not simulate, emulate an external threat actor who has compromised a user or has paid a user, and that internal user is ready to cooperate with them to allow them access. All right. Now, the machine we got access to had services running as a user. Some backup services were running as a user. That user has access to read some log files from each of the machines, and then those logs were saved into not a syslog, not any SIEM device, but those were saved into a database. And to avoid having multiple agents on machines that would, let's say, read logs or read stuff and save somewhere, we basically found out later on, let me quickly finish that one. we basically found out that one of their employees actually who would monitor the emails related to any complaints or feedback or anything at all, they had their emails exported and saved to the same database. And we had access to the database like on second day of our operation. And we never thought of actually going through it, because we simply assumed that all we would have in that database would be logs for backup. That was not the case. Right? So why I'm lecturing you on this is always make sure, always spend time, whenever you get access to a database, spend some time going through it. And be careful, all right? Especially the ones, the red teams and penetration testers from us. Many of us have never seen actual production databases. There could be absolutely millions, if not billions, millions of records in a database. Do not run queries on them blindly. Your nicest of client would be enraged if you run something like that on a production database. I mean, that is absolutely no. So be careful, respect databases, and then they will show you the way to victory. All right. Having said all of that, now what if you ask me, okay, all of this was nice to hear, that sermon was pretty good, Nikhil, but what if we actually still want to have command execution by using databases? I've got you covered. Database links is something, or SQL Server links, that is something that could help you in achieving that goal. So what are database links? Think of it as something like this. Let's say there are 3 databases. A, B, and C. And let's say there is a user who has public access. On database A. Now, what SQL Server links or linked SQL servers to is you can establish direct TCP links between SQL servers. Now, let's say this link between A and B is created using a user called DB user. Now, DB user is a database user that is created on SQL Server B. You can use DB user's credentials from A to create a database link. Similarly, let's say there is a link between B and C that is created using SA. SA of what? Which server? Of server C. Now, thanks to these links, effectively, this user has public access on A, DB user access on B, and SA access on C. All right. This means that although initially the user's access would seem to be useless, there could be a database link node C here in this case, where you may have privileges like SA that allows you to, let's say, enable the XPCMD shell procedure. That in turn allows you to run commands on it. All right. And because these are direct TCP links, even if there is, let's say, a forest trust here and here as well, this would not impact the database links. And I always like to make that joke here so that you remember it, that database links are like love. They understand no boundaries. All right. So be it a domain trust or a forest trust or anything else, if there is a database link between different SQL servers, you would be able to replicate this permission or this privilege. Right. Now, how do you enumerate these database links? You can use get SQL server link from PowerUp SQL, or you can manually enumerate. So the information about SQL server links is stored in sys servers in the master database. So here, if I run get SQL server link on the US MS SQL instance, the instance that we have access to, you get to see that there is a database link here. The link name is this, and the database is linked to another SQL server. Please note that database links could be created to a SQL server or any other OLEDB data source, like even with Excel files or Excel sheets, right? Or we can do it manually. You really want to do that? Using HED SQL, which is a free client for accessing multiple databases. So we want to access a SQL server over TCP/IP. What SQL server? US MS SQL, using our current authentication. That is what we have on US MS SQL. Now, if I run a query here, result of this would be the same as what we saw for get SQL server link from PowerUp SQL. We have a SQL server link called 192.168.23.25. It is a SQL server link. It has RPC or RPC out calls. That is, you cannot send remote procedure calls across the link, but you can access data. Right? Now, as we saw in that diagram, there could be multiple nodes in a database link. I mean, guys from NetSPI who wrote this PowerUp SQL tool, they have seen up to 128 nodes in a SQL server link chain. The maximum that I have seen is 7. But they have seen it up to 128 nodes. So how do you enumerate the chain? You can do it this way, for example. So what does this query do? This is the database link on US MS SQL. So on this link, now we are once again enumerating if there are other links. So if I now run this query here, you would see that on 192.168.23.25, that instance is DB SQL prod. DB SQL prod has a connection to DB SQL SRV. DB SQL SRV is once again a SQL server. It also has RPC and RPC out disabled, but data access is enabled. Right? And so on. I mean, we can keep going through one and another node. I mean, we can keep hopping through nodes. Although keep in mind that this handling these single quotes quickly becomes a pain because this keeps doubling. So if you want to check it for the next instance, you have 2 single quotes. For the next one, there would be 4, 8, 16, 32, and so on. So to ease that, we'll come to this in a moment. To ease that, we have get SQL Server link crawl. So we have been using get SQL Server link up to now. You have get SQL Server link crawl. That, as the name suggests, crawls through all the database links that it could, till it could not find anymore. So in place of get SQL Server link, we simply run get SQL Server link crawl. There's a question, let me answer that. I remember that there is a possibility to block RPC or a similar protocol that is used here, that is used for stored procedures across these links. Is this a default or a particular security setting? That is a default one, I am group. And that is the question from Real Mom as well, I believe. RPC out simply means that you would not be able to run remote procedure calls. That's a default setting. No, that's not a default setting. I mean, when you are creating, if you are creating a SQL Server link, you have the choice to turn it on or off. However, RPC is considered to be dangerous. So you would not always find RPC and RPC out to be enabled. Right? So what are remote procedure calls? What is this RPC? Stuff like this. All right. When you would like to execute a command on a particular instance, that is what RPC and RPC out helps with. All right. Another question is, can I do something with RPC true and RPC out false or vice versa? To be honest, I'm root. I've never tested that. Whenever I have the opportunity to use that, I either enable both of them or I've found both of them enabled. So to be honest, I've never tested if that makes a difference. Having said that, we can actually test that in the lab. We have to enable RPC and RPC out on one of the instances in a few seconds. So we can always test that, but I have actually never tested that. Back to this. Now here, if I run this get SQL Server link crawl, it, as the name suggests, crawls through all the instances. So the first one is USMS SQL. We have this as the login. We do not have sysadmin privileges. There is one database link from this one. Then comes the next one, 192.168.23.25, that turned out to be DB SQL prod. Now we are here. The link login is DB user, and DB user is a sysadmin, which is good. And from here, we have a link to DB SQL SRE. On DB SQL SRE, we are here. The link login is SA, and of course, we have sysadmin privileges here as well, thanks to the link login. All right. So effectively, so where we are right now, we are targeting db.local right now. We'll see that in a moment, how we can actually move to that. Right? Now there is another question. Was RPC out and RPC, these two settings that we were talking about, RPC out, RPC and RPC out, are these a per database or per link setting? This is a per link setting. So when you create a SQL Server link, then you have the option to turn it on or off, right? So here, now here is a quick assumption, a big assumption actually, that we have. Now, XPCMD shell has been always disabled since past 5-7 versions of SQL Server, like for past almost 15-16 years. But we can always check if it is enabled on any instance. How? To get SQL Server link crawl, we pass a query. We simply want to run a command using XPCMD shell. A quick assumption that we make here in the lab is that it is actually enabled on one of the SQL servers. Why? I mean, I actually wanted to get this command execution by abusing a SQL injection, but didn't want it to mix the application security part here. So in place of doing that, in place of abusing a SQL injection, we simply assume that for some business reason, this is enabled. All right, that's a lab assumption, just to keep focusing on what we have at hand right now. So when we run this, when you specify dash query, get SQL Server link crawl tries to run this query on all the nodes of this link, and turns out that on one of the nodes, on the second node, it was successful. But the privileges that we have are pretty trivial. This is a network service, MS SQL Server. I mean, you do not have local admin or any interesting, not even a domain user privileges there. But let's get a reverse shell here. So we start our Netcat listener. Turn on our HFS web server that serves stuff. And here, in place of who am I, we would now like to run these download execute cradles. What are we doing right now? Because we will be using a PowerShell reverse shell, we first download and execute a script block logging bypass. Then we download and execute an MZ bypass. And finally, we download and execute a reverse shell. Please note that this invoke PowerShell TCPX is nothing special, but simply invoke PowerShell TCP with the function call right there. Let me find that out for you. So invoke PowerShell TCPX is simply contains the function call right there in the script. That's it. Let's run this. You see that we got a connect back or SB logging for MZ bypass and reverse shell. If you see here, we got a connect back as MS SQL Server on DB SQL prod. So what do we have here? We have some interesting privileges. This is definitely a service, not a user. You have SE impersonate and SE assign primary token. What these two, I mean, that one is assign primary token is disabled. You have SE impersonate. What SE impersonate allows you to do? If this was a server 2016 machine, you could actually escalate to system using this privilege. It may still be possible on a server 2019 machine by using some of the potato category of exploits. Right? However, we are not interested in that right now. I mean, we do not want a local privilege escalation here. Now, what can we do with this? If not local privilege escalation, what is it that we can do? Please always keep this in mind. What is this user? This user is the service account of the SQL Server. And a service account always have sysadmin privileges on the SQL Server. What does this mean? This means that we can make changes to the SQL server whatever changes we want. On which one? On DB SQL SRV. Sorry, on DB SQL prod, our second node. We can make whatever the changes we want. Now, what is the change that we would want to do, let's say? We want to compromise DB SQL SRV. So what we would like to do is some way to enable XPCMD shell on DB SQL SRV. How can we do that? Recall that SQL Server links are created on, in this case, the link between DB SQL prod and DB SQL SRV is created here. So what are we going to do? We are going to make changes to the properties of SQL Server link to allow RPC and RPC out. Right, so what do we want to do? We want to enable XPCMD shell on DB SQL SRV. How can we do that? We can do that using this command. But to be able to run this command, we must have RPC out enabled on the SQL Server link. A correction to an answer that I gave you, I am Groot. The RPC and RPC out are per database, not per database link. So it is per instance. All right. I stand corrected here. It is per instance, per SQL Server instance. So let's enable RPC and RPC out here. How can we do that? We will use invoke SQL CMD for that. What is invoke SQL CMD? It is a commandlet from the SQL PS PowerShell module that is installed when you install a SQL Server. Let's run this to enable RPC, enable RPC on DB SQL SRV. Why are we able to do that? Because we have sysadmin privileges on this SQL Server. Why? Because this reverse shell that we have on it has sysadmin privileges because it runs as the service account. You can ignore this error. This command was actually successful. Let's also enable RPC out now. Right now, we can enable XPCMD shell on DB SQL SRV. So you want to execute this command on the SQL Server DB SQL SRV. Finally, enable XPCMD shell. Now, if we run the whoami command here, you would see that now we have an output on DB SQL SRV as well. All right. And to be absolutely sure that this was the reason, these changes was the reason why XPCMD shell was enabled. Let's remove the stuff that we have enabled. That is, let's disable XPCMD shell. All right, now we are setting 0 to it. Let's disable it on DB SQL SRV. And now if I run whoami once again, you would see that the customer query once again comes blank for it. Let's also test if it was actually because of the settings that we changed for RPC and RPC out. Was it actually because of that we were able to enable XPCMD shell? Let's set these values to false again. RPC and RPC out. And now if I try to enable XPCMD shell, see that? So we effectively made changes by using our sysadmin privileges. We make changes to DB-SQL prod so that we can enable XPCMD shell on DB-SQL SRV. Let's re-enable it. We disabled it for some testing. I run this XPCMD shell, who am I? You would see that we have, once again, we have execution hit. Now we can exit from this reverse shell. Let's run our listener again. This time, in place of running this command on DB-SQL prod, we want to run it on DB-SQL SRV. How can we do that? We can simply specify query target here. If we do not specify query target, as you would see here, the command would be executed on all the machines. We do not want this to be executed on all the machines, but this time we want to run it on DB-SQL SRV so that we can have a reverse shell as SRV DBA. So let's run this. And here on our reverse shell, we would have a connect back from DB-SQL SRV as SRV DBA. Right? If you look at the environment variables here, you would see that we are now apart. This reverse shell is from db.local forest. Right? And that was our hands-on 26 actually. Get a reverse shell on DB-SQL SRV in db.local forest by abusing database links from US MS SQL. So that is where we are. There was absolutely no connectivity, no forest trust between TechCorp and db.local. Yet we abused database links to finally get a foothold on db.local. Right? Any questions here? Then we can take a break. Oops, okay, that's fine. Okay, welcome back. So there are a couple of questions. One is, uh, if you could elaborate on the trusted property of SQL databases like MSDB and where this matters. So if a database is marked as trusted, that means it is a trustworthy database. What is a trustworthy database? Such a database can access external resources like network shares, other databases, and there is a very common privilege escalation technique. If there is a stored procedure, let's say a DB owner creates a stored procedure, uh, someone can escalate their privileges by abusing a stored procedure created within a trustworthy database. Because it is a trustworthy database, they would be able to run it as the DB owner. So if the DB owner is, let's say, a sysadmin, then they would have their privilege escalated. So that is the importance of a trustworthy database. By default, other than MSDB, I don't think any database is marked as trustworthy. You should absolutely do it after, if you understand what you are doing and the possible repercussions of doing that. You may like to, I'm Groot, you may like to take a look at the blog posts by Scott from NetSPI. They blogged about it years ago when they were writing Power Up SQL. So a fantastic resource to learn more about SQL Server hacks. Another question was, let's say if student user did not have access to the MS SQL Server, we would try with other accounts that we have compromised. Yes, exactly. You would. And as you mentioned, and I'm Groot mentioned, Pongit, you can also run brute force attacks against SQL Server instances. Not, of course, for the Windows, that is domain authentication, but the database users or database roles. Why? The reason being, no one ever monitors, or rarely would anyone monitor brute force attacks against SQL Server or database roles. And even if I ask you, I mean, not you specifically, Pongit, the class, if I ask you all that, do you know where are the SQL Server logs stored on a Windows machine? Many of you would not even know that. I mean, not condescending you or not making a remark on all of you, but that is what the state of database security is. Right? All of us would know, okay, if we run brute force attacks, let's say against Windows users, there is a possibility of lockout, or there is a possibility of at least detection. But in case you are running brute force attacks against database users, not Windows users that unmap to database roles, but the database users, the possibility of detection are low. Of course, compared to Windows or domain users, it's dramatically low. You can actually, that is one brute force attack that I recommend, that you can at least give a shot. At least if it is not a production database, then you can give it a shot. Right? So this is how you can actually move to db.local. That was our hands-on 26. So what we did was we abused a database link to get a foothold on the DB SQL SRV server in db.local. Now we are not done yet with cross-forest attacks. There are a couple of more attacks that we can take a look at. Abuse of FSPs or foreign security principles is one more thing that we may like to take a look at. FSP, or a foreign security principle, represents a security principle in an external forest trust or special identities. So you will find authenticated users and enterprise DCs added to the foreign security principal container on a DC, or if there are any users that are added to a domain local group, then that would also show up in FSP. So this is what it looks like. Let me show you that on a DC. This is the container on a domain controller that lists all the foreign security principles. Because this is a forest root and no foreign security principle is added to a domain local group, this turns out to be empty here. Right, let me show you it somewhere where we would have some visibility. Bring up the password for the DC. Just give me a second. So our FSPs would be on. Let me show you that on the command line. I could not actually log in right now. Okay. Sorry. So FSPs are security principles that are added to a domain local security group. So this allows these security principles to access resources in the target forest. So what are domain local security groups? There are domain local, global, and universal, three type of groups in Active Directory. Domain local are groups like the built-in administrators group, that is a domain local group. Groups like domain admins is, I believe, a global group, and so on. So you cannot add, let's say you have two forests and you would like to add a user from one of the forests to the domain admins group of the another one. You cannot do that. Foreign security principles can be added only to the domain local security groups. So this was once upon a time, this was used to manage multiple forests from a single forest. So what organizations would do is users from or administrators from one of the forests would be added to the built-in administrators group of another forest so that users from one forest can manage stuff in another one. Now, unfortunately, a lot of organizations still continue using that. Or some organizations have simply abandoned that, but have not removed their FSPs. So often FSPs are either ignored, misconfigured, or too complex to change or clean up in an enterprise. Because many times, no one would know that if you remove a foreign security principle, what would it break? Right? Well, as you might already know, a lot of times it simply comes down to the inventory, not in terms of machines or computers, but in terms of privileges. Why does someone has a privilege? Why is someone added to a group? Why is a foreign security principle added across forest? So a lot of times it simply comes down to managing that inventory, documenting that privilege. So how are we going to abuse FSPs? We are going to try and enumerate using Power View or the AD module that if there are foreign security principles added in db.local, right? We have a reverse shell on db.local as SRV DBA that we got by abusing the SQL Server link. So we are going to check if there are any FSPs in db.local that we could abuse. That is one. Now, at least in case of FSPs, they at least show up in the foreign security principles container. But please note that that is not the only way to have access across forest. ACLs can also be used to provide access across forest. And unfortunately, unlike FSPs, ACLs do not show up in a special container. And the only way to find them out is regular ACL auditing. So you can have a foreign security principle or a security principle from another forest that would have, let's say, full control over your administrative holder or replication rights over your domain object, and it would not be flagged as something that is foreign. Unless you are doing ACL auditing, you may not even notice. And that actually makes cross-forest ACLs absolutely a security nightmare. It is indeed. The biggest reason, as I said, the biggest reason for that is you do not need any specific setup. There is no limitation that you can, let's say, add it over only domain local groups or something like that. Absolutely not. Wherever there is a possibility of an ACL, you can simply add a cross-forest ACL. Recall our discussion on security descriptors, right? Where we had access to partial remoting, WMI, and remote registry by modifying their security descriptors and adding SID of a user that we own. Right there, we can also add a SID of a user. That is, we can add an ACE for a user that belongs to a different forest, and it would be absolutely fine. It would be accepted. And it would not show up as anything critical or specific or high privilege. Absolutely not. Right? So this means that we would abuse that as well. We will try and check if there are any from db.local, do we have a cross-forest ACL or cross-forest ACE that we can abuse? How can you find that? We can use that, let's say, with the help of Bloodhound ingesters, that is Sharphound, or we can use Power View's Find Interesting Domain ACL to find out any such interesting domains. Any such interesting ACEs, sorry. Right? So with these two things, let's move on to our hands-on 27. Using the reverse shell on db.local, execute cross-forest attack on dbvendor.local by using ACLs. After that, enumerate FSPs for db.local and escalate privileges to DA by compromising the FSPs. Do this. There is a question. So if we would add enterprise admins of forest A to the FSP group of forest B, they essentially would be all powerful in both forests? Yes. Not the FSP group. I would say call it a domain local group, like built-in administrators. And this, I mean, fortunately, I see this less and less, but still there are so many organizations who keep using this. A user who is a, let's say, enterprise admins or member of enterprise admins or domain admins in one forest would be added to the built-in local administrators on the DCs of other forests or other, I mean, no need in case of within a forest of other forests and domains within that forest, so that those forests and domains could be managed from a single one. And this at least was, as I said, I do not see this as ubiquitous as it used to be. This is the reason why Microsoft introduced the PAM trust actually. Right. So let's do this hands-on 27 now. We have this reverse shell on db.local. Let's get Power View here. So before we can download and execute Power View in memory, let's run our MZ bypass here so that we can now download and run Power View in memory. That we got a connect back for Power View from 23.36. Let's clear this. Now let's first enumerate if there is a forest trust for db.local. So db.local has a bidirectional forest trust with db-vendor.local. Okay. So let's find out any interesting cross-domain, cross-forest ACLs or any ACLs and interesting ACLs in db-vendor.local. So here, and this is very simplified, so it is easier for me to explain and you to understand. What we will find out that there are DBX SVC users in the db-vendor.local domain where SRVDBA, the current user with whose privileges we have a reverse shell that has gen recall. Recall how we learned to read ACEs on object DN, DB30 SVC, identity reference name, SRVDBA, has active directory rights, generic all. All right. This simply means that with our current privileges, we have generic all, full control over multiple users in db-vendor.local. So what we would do, something that is not very OPSEC safe, but here that is the quickest way of achieving our goal. Let's reset password of db1 SVC using set domain user password from Power View. So what are we doing here? Using the set domain user password, we want to reset password of db1 SVC to this. This user is in db-vendor.local domain or forest. Let's run this. Done. That's it. That was actually our first task, execute cross-forest attack on db-vendor.local by using ACLs. Right? You may or you would not be so lucky in a real assessment. You may not be. I mean, the kind of misconfigurations that you will find in an actual environment are always mind-boggling, but you may not be that lucky in actual assessment. Here, I'm using full control and the topmost privileges here, just so that it is easier to grasp and for me to explain the gravity of such attacks, the importance of such misconfigurations or configurations. All right, the second task is to find out FSPs in our current forest in db.local. So let's simply run find foreign group here. So what we would find out here is there are so many FSPs added to the built-in administrators group, the domain local administrators group of dbdc, the domain controller of db.local, right? Now, db.local has just one trust relationship, right? We enumerated that here. There is just one trust relationship, that is with db vendor.local. That means that this member distinguished name that we can see here, this must be a user in db vendor.local. There is no other foreign security principal that can be added because there is just one trust relationship. So what we can do is we can actually list all the users in db vendor.local and then filter based on this object SID. All right, let me see. Please note that there is at least one user for all of you, I mean, who share this lab instance. So check what SID is for your user. All right. And how do we find out? How do we resolve the user? We can list all the users in dbvendor.local and filter the ones, or filter the one whose SID is this. Right. So from all the users, we filtered out using where object, the user whose object SID equals this one. And that actually turns out to be db1svc, of course, the user whose password we reset. What does that mean? We can actually access the dbdc using winrs using the credentials of db1svc. WinRS, we want to connect to dbdc on db.local with this username. Note the domain here, it's db vendor, not db. And that's the password that we set. And if I run who am I here, that will run. Please note that because it is a fragile reverse shell, if you use CMD here, there would be no output redirection and your reverse shell would be stuck. Right? So we can run only one command at a time here in this reverse shell. Right? Yes, not my user, the user. So question is, your user is a member of FSP, not my user, the user that from dbvendor.local whose password we reset, that user is a member of FSP. Not member of FSP, it is an FSP added to the built-in administrators group of db.local. Question is, I don't know of a command that puts find interesting domain ACL for the current identity plus all groups recursively together. Let me see if I can put something together. I'm pretty sure that there is no such thing in PowerView. We have to fall back to Bloodhound for that. Let me see if I can put something together for that. Now, where we are right now, By abusing database links, we got access to DB SQL SRV. From DB SQL SRV, we accessed dbvendor.local, did not compromise it fully, but we got access to a user, dbx svc in dbvendor.local. Turns out that dbx svc is added to the administrators group, built-in administrators group of dbdc, and therefore we could access that, and we compromised db.local. Right? Now, this was, of course, FSPs and adding ACLs across forest is something that Microsoft was and is worried about. So Microsoft rolled out PAM Trust to make it easier to manage different forests from a single forest. So a PAM Trust is what is the basis of a red forest, ESAE. Although ESA is now officially retired, Microsoft recommends that if you already have the setup, you can keep using it. And if you look at their retirement announcement that was somewhere an year back, you would see that Microsoft says that they would internally keep using Red Forest. All right. However, we are not setting up a Red Forest here. Absolutely, that's not easy to set up. So the idea of a PAM trust is if you have, let's say, a forest called Bastion or Bastion, the way you pronounce it, it's entirely on you. And then there is a production forest. So multiple forests. Now, the idea of PAM trust is if PAM trust is enabled, that is, if PIM enabled is configured using NetDOM, all SID history is allowed this way. In all the cases, the trust would be this way from production to Bastion, so that the access is from Bastion to production. And from Bastion to production, you would have all SID history enabled, even the high privilege one. So a basic explanation of how PAM trust works is because SID history is enabled for all of these, there is a mapping done on the Bastion for called shadow security principles. These shadow security principles would have a SID history of 519 for each of the production forest. What does that mean? That means the users in the Bastion forest who are added to the shadow security principles could access all the production forests as enterprise administrators and therefore can securely manage it. Why securely manage it? Because there is no way back from any of the production forests. It is a one-way street. And please keep in mind, that is just one of the things that you would actually implement in a Red Forest implementation. But this is something very interesting. Now, why are we discussing in the lab? A few years back, and that is where I derived this from. I was included as an external subject matter expert I hate that term, but that was the case there. In a post-breach analysis of Active Directory environment of an organization. So they hired like the top of previous to their hack. It was a US based company, so they had like top red teams that you could think of. All right. Now, one of their previous red teams or red team consultants, I mean the consultants who did the red team operation, they recommended that you either implement a red forest. I mean, they advised them to secure their management of multiple forests or domains. So they hired another consultancy who would help them in implementing it. Turns out what the consultancy did was their current forest, which was called HQ dot their primary domain name, the entire forest was created as a bastion or promoted as a bastion, and every other forest could be managed using that. There was absolutely no care on who is onboarded to this bastion. And I'm not picking that up. That is where I got the idea of using this here. All right. And that is the point of our discussion here. If you are using a bastion or a red forest to manage other forests, the security of the entire setup is as good as your onboarding workflow here. If this onboarding is not foolproof, if there are leakages, if non-admins can be onboarded, if non-admins can access this without a jump server or a PAW, if the users are not housed in a physically secure location, then your forest would be at risk. Because there is unhindered access to all of your production from this. Right? Does that make sense? That's what Bastion or Red Forest setup is, at least the PAM part of it. And that is what PAM Trust allows you to do. How do you sorry, how do you find out if PAM Trust is enabled on a forest? So we will come back to this slide in a moment. You can be absolutely sure by looking at this container. If shadow principal configuration services, if shadow principal configuration is not null, if it is populated, that is, if there are some shadow principals that are configured, that means that you have PAM Trust enabled between two forests. And once you know that, you know a target. Once you find out that, okay, these users are a member of the shadow principal configuration, compromise that user, and then you can access all the production forests that are managed using that Bastion or Red Forest. All right. And that is our last hands-on 28. Compromise production.local by abusing PAM Trust between Bastion and production. Bastion and production, these two are our last standing forests. Right, so let's first enumerate some things here. First and foremost, how do we compromise Bastion? So it is pretty straightforward in case of our lab. We will take a step back and execute our enumeration, we'll start executing our enumeration against Bastion.local, assuming that that is reachable. We are assuming that Bastion.local is directly reachable from our current forest, which is fine actually, because as we'll get to see later on, there is actually a trust relationship between TechCorp and Bastion. So after some enumeration, when we list foreign security principles in Bastion, let me import the AD module. And we list the foreign security principles in Bastion, this is something that stands out. There is a foreign security principle, this SID. All right. Now, if we list trusts in Bastion.local, you would see that it has just two trust relationships. One outbound with TechCorp.local, our current forest, and one inbound with production.local. What does this mean? Outbound means that the trust goes from Bastion to TechCorp and access goes from TechCorp to Bastion. All right. Trust goes from Bastion to TechCorp. Therefore, the access goes from TechCorp to Bastion. Inbound means access goes from Bastion to production. So what does this mean? This means that this SID is for our current forest, TechCorp, and this would be the built-in administrator. Not the built-in administrator, the default domain administrator. So this should be the default domain administrator of TechCorp.local. Let's check that. Let's list all the users in TechCorp.local and check what, I mean, that is for sure. This SID is absolutely going to be the default domain administrator. All right. So what does this mean? This means that the default domain administrator of TechCorp.local is added to the built-in administrators group of Bastion.local. One of the simplest cases of messing up the onboarding of administrators on Bastion, right? We already have secrets of the administrator of TechCorp.local. So let's start a process using overpass the hash. Let's start a process as the administrator of TechCorp.local. Right. Now, as this user, let's run a DC sync against Bastion, administrator of Bastion, so that we could access the domain not as an FSP, but the administrator itself. So what we are doing, we are running a DC sync against administrator of Bastion.local. Let's run this. Why are we able to do this? Because the administrator of TechCorp.local is added to the built-in administrators group of this forest. Let's copy this. And now using overpass the hash, let's start our process as the administrator of Bastion.local. This process runs as administrator of Bastion.local. Now let's copy InvisiShell shell there because we would like to run some commands, some AD module commands. Access Bastion DC using WinRM. Start an InvisiShell shell session. And we would like to now check for PAM trust. So as we discussed on the slides, the best way for that is to search for or search this container if shadow principal configuration is not null. If there are any entries here, that means that PAM trust is enabled. Right? So what are we doing here? We are listing all the AD objects under this base. And from the output, we would like to select name member and the property MSDS shadow principal SID. So if I run this, there is a shadow principal configuration, of course, here, whose name is Prod Forest Shadow Enterprise Admin. That could be any name, that's a given name. Member of that shadow principal configuration is the default domain administrator of bastion.local. And what is the MSDS shadow principal SID? That is, what are the privileges that shadow principal configuration has on production.local? That is enterprise admins. All right. This must be SID of production.local, but we don't even want to know that because this means enterprise admins. Bastion.local has just one production forest with it. So this must be SID of the production.local. Right. A question is that can we use this command as well? Check for PAM trust. That is, if we filter for a trust whose forest transitive is set to true and SID filtering quarantine is set to false. Sort of, that is not 100% guaranteed. Even if a forest is not set to be PIM enabled, you may find both of these properties. SID filtering forest aware, if you recall, this was true even if simple SID history was enabled between EU.local and EU-vendor.local. Same goes for this one. Right, so the most definitive way actually is this. All right. Now, how do we access production.local now? We could not do this, although technically this should be possible, but due to some Kerberos gochas, that would not be possible. Otherwise, assuming that we know that production-DC is the name of DC in production.local, not do that. In fact, I mean, there is no need to assume that. And actually run enumeration commands against production.local from Bastion. Right? Still, stuff like this would not work. Right? So what can we do, and what can we do in such case? To be honest, I've not been able to find out why we could not access production DC from Bastion DC just like this. Right? So what are our options now? Now, we can try it assuming that we have access Assuming that we have access to production.local from our student VM, can we access production.local from our host machine, that is from our attacking machine? So let's try that. Let's start another process as the administrator of bastion.local and try to access. Let me copy this command. And the name. This makes sense. WinRS says that cannot find the computer production-tc.production.local. This makes sense. Why? Because there is no DNS entry, the one that we fix this. What's that? Okay. So here there is no DNS entry for production.local. Why? Because TechCorp is not aware of existence of production.local. TechCorp has no trust relationship. Right? Those of you who have ever set up a forest trust, that is the very first requirement. There must be DNS zone and entries for the other forest. Let's see if we can actually get the IP. On the Bastion DC, if I run get DNS server zone command, that gives us the IP address of at least one domain controller in production.local. And as we have found out, there is actually just one machine, just one domain controller there. So this must be then the IP of production DC. So let's use that here. This says if you want to use an IP, destination must be in the trusted host list and explicit credentials must be provided. So let's first modify the trusted hosts. What is this trusted hosts? You can specify it is a setting for WSMN configuration. And you can specify if you would like to trust a specific host for delegation. I say that we will trust all the hosts from our attacking machine. Let's try this now. Still doesn't work. Let's try partial remoting. Why? Just to check if that works. And later on, that would be actually required. So we get the same error. The destination must be in the trusted host list and explicit credentials are provided, but we do not have explicit credentials. We do not have credentials for, whoops. We do not have credentials for administrator of production.local. What do we have though? We have the keys of the user whose SID history contains enterprise admin privileges. So let's go for implicit credentials here. Now we got an access denied. So at least we made some progress. All right. We are getting a different error. Now, why are we getting an access denied here? This needs RC4, not NTLM. What does that mean? See, what are we using here? We are using AES keys here. So in place of the AES key of the administrator of bastion.local, if I use NTLM hash here, and here I would use the same command. Not get an access denied. Okay, let me log off once then. So you got the point, right? We cannot use AES keys with IP address for partial remoting or WinRM. So we are going to use the NTLM hash. So let's start a partial process. As the administrator of bastion.local, this time we are using RC4, that is NTLM hash. We start a PowerShell process using that. And now if we would like to access production.local, we would be able to do that. As the administrator of bastion.local, we can now access production.local. Right, and that was our last hands-on, and these are all the attacks that we executed. You can find this diagram in the course OneDrive as well if you would like to, or keep referring to this if you're lost. Now this ends our attack part. Now let's talk about detection and defense. Are there any questions that you would like to ask? No questions? Okay. So let's split the defense in 5 categories. Protect and limit domain admins, isolate administrative workstations, secure local administrators, time-bound and just enough administration, and isolation of administrators in a separate forest and breach containment using tiers and ESAE. So let's first talk about protecting and limiting domain admins. Please note that I'm not a blue team practitioner. So the suggestions that I'm making here are either on other detection engineers and blue teamers' experience or stuff that I have seen and abused over a decade. So first and foremost, reduce the number of domain admins in your environment, and absolutely do not use domain admins for anything other than accessing the domain controllers. As we have seen during the course, if domain admins are not controlled, if their access is not controlled, I mean, you would see environments where domain admins would be used to run pretty much everything. And I would never forget one of my clients, they shrugged when I used to work for a consultancy firm like 11 years ago. So we were closing a quick assessment. We of course get DA, etc. That was, the network was in a poor state. So the client simply shrugged and said that everything just works if we are using domain admin privileges. I mean, while the discussion, which was surprisingly very friendly and very open, We asked that why were you running every second service, every agent, your SQL servers and whatnot as DA? So the answer was everything just works if we use domain admin privileges. So try and reduce that. Right? Now, if you ask me that is there an Active Directory security sin, I would say yes, there is one. That is running a service with a domain admin. You would be judged if you run a service as a domain admin. The biggest reason for that is there are some superb credential theft protections, like, of course, credential guard, protected users group. Now, all of these protections make it very hard to extract credentials from the memory of LSS process. That way, your credentials are secured. However, if you are running a service as an account, the account's credentials are stored and can be retrieved in clear text from the LSS secrets registry. And there is no protection mechanism like credential guard or ASR or protected users group or whatever your latest marketing lingo is, right? Your XDR, your ZDR, or whatsoever that focuses on LSS secrets. Absolutely not. It is the memory of the LSS process that everyone likes to protect, right? So absolutely never run a service as a domain admin. Otherwise, it is a recipe for disaster. And you may like to set account is sensitive and cannot be delegated for DAs. So couple of things that we have discussed here are actually something that Microsoft already provides you and can be very easily implemented. You can protect and limit domain admins by adding them to the protected users group. This was introduced way back in 2012, more than a decade ago. Microsoft says that this group is added for better protection against credential theft by not caching credentials in insecure ways. Any user added to this group has following major device protections. The user cannot use CredSSP and WDigest. So therefore, there would be no more clear text credentials caching. NTLM hash of the user is not cached. Kerberos does not use DES or RC4 keys. That means that theoretically, there cannot be any Kerberosing of a user added to the protected users group. Now, if the domain functional level is also server 2012 R2 or above, following additional protections are available. No NTLM authentication, that is, for example, no pass the hash or overpass the hash. However, AES still works. So you can still use overpass the hash with AES. No DES or RC4 keys in Kerberos pre-auth. AS wrap roasting. That no delegation constrained or unconstrained or any sort of that stuff. That also helps in protecting the users. No renewal of TGT beyond initial 4-hour lifetime. So there is 4-hour lifetime that is set for TGT that cannot be changed or configured. All right. So that also helps. Please note that, however, there are two sort of avoidance or bypasses for the protected users group. As I said here, if you have the AES key, overpass the hash with AES key would still work. And unfortunately for Kerberosing, recall when we were discussing the RC4 OPSEC option of Rubius, the client has absolutely full control the client, that is the client who requests service tickets, it can forcefully downgrade the keys that are used to encrypt a service ticket. That is, Kerberos still works. You can force request or RC4 encrypted service ticket for a user that is added to the protected users group. When we say no delegation, you cannot use constrained or unconstrained delegation. That is, even if a user that is added to the protected users group accesses a machine where unconstrained delegation is enabled, they would not leave their TGT there. Similarly, if you, let's say the default domain administrator in TechCorp is added to the protected users group, you cannot request a TGS that impersonates the domain admin. Please do not configure these with protected groups. Protected users group and protected groups are different. Protected groups are the ones whose ACLs are protected by the admin SD holder container. Those are the protected groups. These are the protected users group. That's a separate group. Yes, AZ, exactly. I mean, that would be invalidated if you generate a golden ticket, let's say, that has a lifetime beyond 4 hours, it would be invalidated after 4 hours. So pretty interesting limitations here. And there are certain requirements, of course. All domain controllers must be at least server 2008. And as we all know, all of the organizations, including the defense forces across the world, have moved beyond server 2008. All right. I mean, there are so many organizations that still use only mainframe, moving to Windows. I mean, let's not get into that. I mean, whenever I see this, I recall a story that I read a few years back about Charles de Gaulle, the Paris airport. So their weather system was running on Windows 3.1, if I recall correctly. And there was a snag, there was an error there. And none of the engineers present on the site was able to do anything about it. So if I recall correctly, they have to actually find out someone who previously used to work there, and then when it could be fixed. But coming back to this, all the DCs must be at least server 2008. Microsoft does not recommend to add all DAs and EAs to this group without testing the potential impact of lockout. So you may not like to add your break glass or emergency administrative accounts to it. Also note that there is no cached logon, that is no offline sign-on. So if you have mobile users, you may have to check if that would be useful for them. And as I said earlier, adding computer or service accounts in this group is useless, as their credentials will always be present on the host machine. All right. How do you isolate administrative workstations? So if you go through Microsoft Securing Privileged Access, it talks about PAWs. It is a hardened workstation for performing sensitive tasks, like let's say administration of domain controllers or connecting to the jump box that takes them to domain controller, managing cloud infra, and so on. So the idea is pretty simple, that your administrators should not access the DCs from their work machines, from their normal machines. They should have a separate machine for administration and a separate one for Facebook, that is for everything else. There are multiple strategies. You could have separate privileges and separate hardware, let's say a workstation and a mobile workstation, for one for administrative and another one for normal tasks, or running a VM on a PAW for user tasks. That is, your physical machine is used to access stuff for administration, and a VM inside it is used for other stuff. Please do not do it the other way around. Right? I mean, breaking out from the VM is always a possibility, But if your PAW is running inside a normal machine, then that would be of no use, right? Because you would always have the God mode over the VM running on your machine. How do you secure local administrator laps that we actually abused in the class? But as I said at that time as well, attack paths that we can map by reading who can read the password in clear text when laps is in use, that risk is far, far less than the risk you have if you have same administrator password on your machines. All right, so use laps. I'm not going to discuss this again because we have already discussed that in detail. For time-bound administration, you can use JIT or just-in-time administration. If you have PAM feature enabled on the first level, you can actually add users to a group with a TTL or time to live. A member time to live can be added. And in my testing, it is absolutely not possible to tamper with it once it is configured. Even if you have the highest privileges, domain admin, enterprise admin, or whatsoever, even with the help of attacks like DC Shadow that can tamper with the schema, I was not able to modify this time. So you can add a user to a group, let's say like domain admins, for a limited time. Right, and this is time-bound administration and just-in-time access. This is something that Microsoft has focused a lot in Azure. So if you look at privileged identity management in Azure, that is where the just-in-time and time-bound administration shows its true potential, its complete potential. All right, users can only activate roles for a certain time, that too with certain work approval workflow. Then there are regular access reviews and whatnot. Another interesting piece of technology, which unfortunately never picked up a lot, is JEA or JAW, just enough administration. If your organization uses a lot of PowerShell for remote administration, this is a fantastic piece of technology. So let's see that there is a group of users in your, or that let's say there is an appliance in your organization that needs to run a particular task on machines. Let's say there is an inventory management system that would like to list services running on your DC. That's it. Now, a lot of time organizations have to provide administrative access for that appliance or for that group of users, because not everyone can list services on a machine. What JEA provides you is a sandboxed, no language mode PowerShell endpoint, PowerShell remoting endpoint, where you have so much control that you can specify that only a specific commandlet with a specific parameter can be executed. That's it. Even with administrative privileges, you would be able to run just one command with one parameter. That's it. You would not be able to run anything else at all. That is what JEA does, and we use it internally for a lot of things. It is a fantastic piece of technology. So if you use with Windows machines and you need to remotely run stuff here and there, then look at JEA. That is pretty useful. Having said that, JEA can also be used for persistence. I covered that in one of my DEF CON talks a few years back. So it is a double-edged sword. Then tier model, although tier model and ESE are retired, but still worth discussing, I would believe, because not all organizations move away from this just because Microsoft wished, and they're still using it actually internally. So the tier model talks about only for administrative accounts in 3 tiers. Tier 0, where the accounts, groups, and computers that have privileged access across the enterprise. So what machines or users should be in tier 0? Your domain controllers, domain admins, enterprise domain controllers, Azure AD Connect servers, ADFS, ADCS, SharePoint, if you have on-prem Exchange, any machine with unconstrained delegation, any user or machine that has constrained delegation to domain admins, all of them should come to a tier 0 machine, to tier 0. Tier 1 contains accounts, groups, and computers that have access to resources having significant amount of business value. So server administrators, jump servers, your database servers, application servers that may come in tier 1. Tier 2 mainly consists of your help desk support IT administrators that have administrative access to a large number of machines. Right? There are two types of restrictions between tiers: control and logon. Control restrictions are what admins control. Logon restrictions are what admins can log on to. So, for example, in tier 0, an administrator can manage the domain controllers. If required, they can manage or control if a machine or a user moves to the lower tier, but the other way around is not right. However, in case of logon, it is absolutely opposite. Under any circumstances, administrators from tier 0 cannot access machines in tier 1. However, if required, administrators from tier 1 may be able to access certain machines in tier 0. How are these tiers managed? Using ESAE, Enhanced Security Admin Environment, or the famed Red Forest. So the idea is to have administrators for tier 0 live in a separate forest. There is just one-way access. There is selective authentication, SID filtering, and all of that protections in between, so that there is no way to go back here and compromise your admins that manage your tier 0. And that's just one part. I mean, super simplified what ESAE is. Right? Then we have endpoint detections like credential guard that protects credentials, both read and write of credentials in the memory of LSS process. So this stops extraction of credentials and attacks like PTH and over PTH. But please keep in mind that tools like Mimikarts using its own SSP can bypass credential guard. And once you have a set of credentials, there is not always a need to use your Windows machine to pass those credentials. All right, once you have a set of credentials, you can simply run, let's say, a SOX proxy and use those credentials from a Linux machine. So there would be no need to bypass the writing of credentials to the memory of LSS process. WDAC, Windows Defender Application Control or Device Guard. This is also something that we have discussed in detail on US Jump. So no need to discuss this. Make sure that you check out the LOLBAS project. I think I mentioned this in the hands-on where we land on US Jump as well. Now, MDI. So we saw that when we are executing attacks against the DC, like let's say Golden Ticket or DC Sync, etc., MDI could be a pain. So if I pick up Microsoft's definition, MDI can identify, detect, and investigate advanced threats, compromised identities, and malicious insider actions directed at your organization. So MDI sensors are installed on DCs and can also be installed on Federation servers or servers with ADFS role. And all the analysis and alerting is done in the Azure cloud. So at least theoretically, MDI can be used for detecting recon, compromised credentials, lateral movement, domain dominance, and exfiltration. However, as we saw, we can actually bypass MDI. The key is to avoid talking to the DC as long as possible and not create anomalies. So the way MDI works is it creates profiles for all the users and machines. And if there is a deviation from the proper profile that it has, then there could be an alert. All right. So how do we bypass? As we keep doing during the entire class, if you use AES keys for all your overpass the hash attacks, then the encryption downgrade detection by MDI would not bother you. Otherwise, it would. If we have the NTLM hash of a DC, we can use NetSync protocol to get NTLM hashes of other machines that could help you in running the silver ticket attack. This is a protocol that MDI does not care about, so that is a bypass. Also recall in Learning Objective 21, I believe, we discussed that if you use the SID history of the domain controllers group and then run the DC sync attack, MDI is blind to it. Almost always. Right? Then some interesting event IDs for use of golden ticket. Of course, in case of any logon to the DC, if there is a 4672 from a machine, from a user machine, from where a domain admin has never logged in, that is an anomaly and therefore a detection. Same goes for silver ticket. For skeleton key, I believe that is the easiest attack to detect. If you detect skeleton key, then there is a problem. What is the mitigation of skeleton key? Running LSAS as a PPL, protected process light, is really handy. All right. You can turn it on by simply flipping this registry key. That's it. For DSRM and malicious SSP, we can keep an eye, and for admin SD holder as well, we can keep an eye on creation or change of the registry keys in these two cases and change in ACL of the admin SD holder. For Kerberos-Sting is probably the hardest to detect if you do not know what to look for. So there are thousands of 4769s every day on a DC. So how do we detect a Kerberos-Sting? And this list is based on a blog post by Trusted Sec. Filter out the following. For all the 4769s, filter out the ones that has service name. Their service name should not be KRBTGT. Service name does not end with $, so that machine accounts used for services are filtered out. Account name should not be machine at domain to filter out requests for machines. If the failure code is anything other than 0x0, because we want only success, then filter that out as well. Most importantly, the ticket encryption type is 0x17, that is RC4. That would help in filtering out the relevant 4769s. For unconstrained delegation, to be honest, the best mitigation for unconstrained delegation is not to use it. There should not be a reason in 2022 to use it. For ACL-based attacks, all of the ACL-based attacks that we did, including the admin SD holder one, the best defense is actually to regularly run audits. You can use ADACL scanner. You can use tools like Pink Castle, Bloodhound to take a look at them. And then for the most critical ones, you can turn on audit policy. So we'll get a 4662, 5136, and 4670 if audit policy is turned on. SID filtering we have discussed enough. Selective authentication is something that we have not discussed. If selective authentication is configured, users between trusts will not be automatically authenticated. Only those requests that are explicitly permitted at the resource level would be allowed. That is, this is reverse of forest-wide authentication. Final thing that we can quickly take a look at is deception. Something like leaving honey tokens or honey users, but not only for credential compromise. So you can trick a user or an attacker or a threat actor to follow a path that you design in your environment. It is possible. I wrote a script about it a few years back called Deploy Deception, just a POC script, not production ready, of course, that helps you in deploying decoy objects. What kind of decoy objects? Let's say a user that has high privileges, a user whose password never expires, a user that has ACL permissions over other users. So that such users or groups or computer accounts are interesting for an attacker. So the idea is that you deploy such decoy objects, turn on logging for them, and then whenever an attacker interacts with them, you get a 4662. So for example, this command creates a decoy user that has password never expires as a candy for the attacker. And a 4662 is logged whenever this obscure identity or this obscure attribute is read. So tools like NET or Win32 user account or AD module does not read it, but tools like Power Viewer and AD Explorer trigger the logging. You can take it a step further. However, I do not recommend using this in production. You can, for example, add a user, actual user to the domain admins group, but deny logon to them. So in this case, if their credential is compromised, a 4768 would be logged and enumeration will result in a 4662. So if your organization has a mature security posture, then you may like to play with deception a bit. There is a booming market for past so many years on deception, so many vendors. I will not comment on efficacy of anyone. So take a look at them, and if you have deep pockets, if your organization has the basics covered, then probably go for it. Right? A question is, when we used mimicards to extract the secrets of a user, what indicates that those users are currently logged in on those machines or have logged in the past? So I believe you're looking for logon count, that if a user is active, is that what you're trying to check? That if it is a stale user or an active user, if that's the question, then you can take a look at their logon count. So recall our discussion on user attributes. Logon count is the attribute that will show you that. So that would be all from me. Please feel free to leave feedback. That helps us in improving our courses. You can follow me on Twitter. Directly reach out to me on my email. And for other courses and labs, please check out our website. For any lab access, extension, or support, you can reach out to the lab team. And that would be all from me. Please feel free to ask questions, if any. Thanks, Pongit. Thanks a lot. Any attacks with NTLM v2? No, I do not discuss any MITM attacks in the class. I mean, of course, responder is the tool to go for, but I do not discuss that in the class. The question is, the hashes found with mimicards were of current users logged into the target machine? Yes. So the users that either are logged in or if there are services running as those users. Thanks, Spider. Thanks a lot, Real Mom. Any last minute exam tips? If I've not said this already, I would say set up Bloodhound GUI on your host machine. Do not set it up on the student VM in the exam lab to save time. That would save you a lot of time. Those of you who have done CRTP, please keep in mind that CRTE is a step above. So it would not be as straightforward as CRTP. If you get an exam version where a privilege escalation exploit works, there are some exam versions where it works, stuff like NOPAC, etc. They work. If you choose to use that, that is absolutely fine. But please explain that in as much detail as you can. Please explain the vulnerability as much as you can in your report. Otherwise, I have to disallow that. Right? Please feel free to use any tool that you want in the exam. Your paid tools, your Cobalt Strike or whatsoever, we absolutely do not limit on what you can use in the exam. Just explain everything. You should think of it as if you are teaching me. I go through all the reports personally. So think of it as if you're teaching me how to compromise that target exam lab. Our question is, can we use Metasploit instead of Covenant? Absolutely. Feel free to use anything, Spiderweb. I mean, we use the Covenant lab manual as a hand holding. We still do not support it officially. And that's the reason, I mean, very hard to maintain. I mean, if we have to support that officially, then we have to maintain our own version, to be honest. So that's the lab manual of Covenant is just a pointer for some handholding. Are the material and topics covered enough to pass the exam, or there are any surprises? There could be some surprises. Especially, I have to do that to incapacitate spoilers. Having said that, there would rarely be anything that is not covered in the labs. Even if there is something, I can tell you that it would be something that you can very easily find out. For example, let's say if there is a privilege escalation on SQL Server, that is something that you can very easily find out using PowerUp SQL or by just looking it up on the internet. Because this is an expert certification, not 100% of it is from the course. 99% of it is from the course. Couple of things is something that I would expect you to find on your own. And that is why it is a 48 hours exam. Having said that, this is an absolutely doable exam. We do not expect you to go for a second attempt. Even if you have to, that is absolutely fine. But we do not expect you to have to go for a second attempt here. And yes, I go through all the reports. And that is why there is a time limit of 7 business days. I go through the reports of absolutely all the courses that I teach. Right? Are there any other questions? Because there are no more questions, let me stop this. Thank you so much for joining me. I would miss spending my Sundays with you. And I hope that this class would be useful in your career. So thanks a lot, and see you on Discord and probably some conferences or somewhere. Thank you, everyone. The next time. Bye-bye.